The human race is always going to leave a big carbon footprint on the Earth, but it's got to keep finding ways to lessen this impact of fossil fuel consumption. Carbon capture technologies, chemically trapping carbon dioxide before it gets released into the atmosphere, is one approach. And in a report released last month, Cornell researchers disclosed a new method for capturing the greenhouse gas and converting it into a useful product while producing electrical energy. Those researchers have developed an oxygen-assisted aluminum carbon dioxide cell that uses electrochemical reactions to both sequester the carbon dioxide and produce electricity. The group's proposed cell is going to use aluminum as the anode and mixed streams of carbon dioxide and oxygen as the active ingredients of the cathode. That electrical chemical reaction between the anode and the cathode would sequester the carbon dioxide into carbon-rich compounds, while they also produce valuable electricity as an oxalate as a byproduct. In most carbon capture models, the carbon gets captured in fluids or solids, which are then heated or depressurized to release the carbon dioxide. The concentration gas must then be compressed and transported to industries that can use it or sequester the carbon underground. The findings in the study represent a possible paradigm shift. The group reported that their electrical chemical cell can generate a certain amount of energy per porous carbon at a discharge potential with a couple of volts. The electricity produced by the cell is comparable to that as produced by some of our highest density battery systems. Another key aspect of the finding in the generate of superoxide intermediates, which get performed when oxygen is reduced at the cathode, the superoxide reacts with the normally inert carbon dioxide, forming a carbon-carbon oxalate that gets used in a lot of different industries, including pharmaceutical, fiber, and metal smelting. The technology isn't limited to power plant applications, and it can fit really well with onboard capture in electric vehicles. Current drawback of this technology is that the electrolyte, the liquid connecting the anode to the cathode, has a problem with water. So we'll see what happens in the future.